All right, so section 7, chapter 6, looking at areas and area formulas for quadrilaterals. So most of these are formulas that you should know just from growing up. Like you start covering area in 4th or 5th grade. So postulate 22, area of a square postulate. Area of a square is the square of the length of its side, or the formula A equals S squared. So take the side length and square it, and you've got the area of the square. Area congruence postulate. If two polygons are congruent, then they have the same area, which should make sense. If two polygons are congruent, then everything's the same about them, and so the area should be the same as well. Postulate 24, the area addition postulate. Area of a region is the sum of the areas of its non-overlapping parts. So what postulate 24 allows us to do is, if we have a figure that looks something like this, then we can look at that figure as smaller parts that make recognizable shapes that we can find the areas of. So in this example, if I find the areas of these two rectangles and this triangle, and I add those three areas together, then I have the full area of the figure. Kind of like if you were trying to find the area of the floor space in your house. You find the area of each room in your house, add those together, and you get the area of the total area of your house. All right, so then theorem 620, area of a rectangle. Area of a rectangle is the product of its base and height. Formula is area equals b times h, base times height. Or you might be more familiar with it as area equals length times width. That's probably what you covered in your earlier years. So length times width or base times height, same basic thing. Take the long side times the short side. Then you got theorem 621, area of a parallelogram. So area of a parallelogram is the product of a base and its corresponding height. So formula looks just like that of a rectangle. And what you have to make sure of is that your height is actually the perpendicular distance from one base to the other. Don't use the side over here that's at a slant, because this length will be longer than the actual height is. And then area of a triangle is 1/2 the product of a base and its corresponding height. So 1/2 base times height. So take the base and the distance from that base to the opposite vertex, or the altitude, which is the height. Multiply those together and divide by 2, or multiply that by 1/2, same thing. All right, questions so far, anybody? All right, so finding the area of the following figures. First figure here is figure ABCD, is a square, right? Both sides are marked 8 inches. So using the formula for a square, which is A equals the side squared. So A equals 8 inches squared. And 8 times 8 is 64 inches squared. And make sure when you're doing these area problems that you put your answer with the units and the units squared. Right? If no units are given to you, then put u squared for units squared, just to show that you know that whatever it is would be squared in there. All right, so the next one over there, EFGH, is a rectangle. So we're using area equals base times height, or length times width, whichever you prefer to look at it as. So it's going to be 13 inches times 7 inches, and 13 times 7 will be 91 inches squared. So the bottom left, IJKL, is a parallelogram, and they've given us 3 different measurements. Parallelogram is area equals base times height. So what's our base in this picture? Which side length represents the base? The 11. So the base is 11 inches. And which of the other two is the height? The 5 inches, the perpendicular distance from one base to the other. We've got 11 inches times 5 inches for an area of 55 inches squared. And then the last one there, MNO, is a triangle. So using the formula, area equals 1/2 base times the height. So 1/2 of 12 inches being the base times the height, which is that perpendicular distance from that side to the vertex, opposite vertex, which is 9 inches. So our area is 1/2 of 12, which would be 6, and 6 times 9 is 54 inches squared. Questions on any of those four? Anybody? All right, theorem 623. The area of a trapezoid. So this page is figures that may not be as common to you from growing up. You may not remember trapezoid formulas. All right, the area of a trapezoid is 1/2 the product of the height and the sum of the bases. So we take the lengths of the two bases, add them together, and then multiply those by 1/2 of the height. So theorem 624, area of a kite, and 625, area of a rhombus. They both have the exact same formula. They're kind of similar looking figures anyway, but it's area equals 1/2 of the product of the lengths of the diagonals. So take the two diagonals, so going from one vertex to the opposite vertex, take the lengths of those two diagonals, multiply them together, and then multiply that by 1/2 or divide it by 2, same thing. So this page, we've got a kite to start off with. And for the kite, that formula we just went over, area equals 1/2 of diagonal 1 times diagonal 2. So diagonal 1 has lengths of 16 and 8, so making it 24 units. And then the other diagonal is 11 and 11, 22. So we got 1/2 of 24 times 22. So 1/2 of 24 would be 12, and 12 times 22 is going to be 264. And we don't have any units given, so we're going to put u squared on there to show that we know that whatever units it is would be squared. All right. Then the next figure appears to be a rhombus. Look at our diagonals. So we got 26. And 20. So once again, using that same formula, 1/2 of diagonal 1 times diagonal 2. So 1/2 of 20 times 26. 1/2 of 20 would be 10, and 10 times 26, we got 260, and it's unit squared. What's that?
Cut that into a triangle and then rectangle. Each the whole thing. Not that one.
Now we don't have to. We could break it up if we knew enough about it to break it up into a triangle and a rectangle.
Yeah.
But as it is right now, we've got two sides that are parallel and two sides that are not, which makes that a trapezoid. Right? It's not an isosceles trapezoid like what we often expect a trapezoid to look like, but it still fits the criteria of a trapezoid, so we can use the trapezoid formula on this one, which the trapezoid formula is area equals 1/2 of the height times base 1 plus base 2. So 1/2. And if we look, this side has a right angle marked. So that tells us that this side length of 7 is actually the same as the height from the 12 to 6, the base 12 and base 16. So we can use that as the height. That's 7. Then base 1 is 12 plus base 2, 16. So we've got 1/2 of 7 times 12 plus 16, which is 28. And multiply that out. 1/2 times 7 times 28 would be 98 units squared. Questions there?